Hi, my name is Emmanuel Gallegos, and I'd like to thank you for joining me here today to learn about my research into mobile head detection with thermal imaging for skin temperature analysis. Now, what this research really boils down to is we wanted to try to develop a tool that could help users increase their situation awareness with respect to COVID-19. Now, what we mean by that is we wanted to develop a system that would let users get a little bit more information about the people around them to determine if any of them might have fevers. To that end, we developed the infrared fever indication system. Now, this system is meant to, again, give this information to users so that they can determine if they might need to avoid people around them who might have fevers. And it does this with the use of the user's smartphone, as well as a small infrared camera, which is attached to their smartphone. Now, these kinds of systems that are meant to detect fever have existed as far back as 2003, where they were developed in response to the SARS outbreak. And you might have even seen them if you were around back then. They were around airports and government buildings. But those systems were very expensive. And even today, those kinds of systems usually run between about $5,000 and $30,000. And so they're mostly marketed toward schools, government buildings, airports, and large businesses. And there really isn't any kind of accessible option for a commercial grade system that any user could purchase. So we wanted to see if we could develop a system that could achieve similar results using essentially very low quality infrared hardware and the user's own smartphone. So we decided that we would need to develop the system in kind of two stages. The first part of our system would need to be able to detect the heads of anyone that you pointed your infrared camera at. So when you pointed your infrared camera at someone, we needed the system to be able to draw what we call bounding boxes around the heads of the people in the frame. And then once those regions have been located, those would need to be passed to a module that could perform temperature analysis to determine if anyone in any of the people that were captured in that frame might have a fever. And we can do that because these pictures were taken in the infrared spectrum. And infrared energy, or how bright something appears in an infrared picture, correlates directly to the temperature of the object, the surface of that object at that location, at that pixel location. So we can provide an augmented reality type interface that will draw boxes around people as you hold your camera up and then flag you if any of those people might have fevers. And so my research in particular was focused on the first part of the system, which is to see if we could develop a model, a machine learning model that could detect heads from this very low quality infrared data. So the sensors that we're using only have about 120 by 160 pixel resolution, which is extremely low for a camera. That being said, we were still able to achieve excellent results for head detection. Our model achieved an average precision of 95.6%, which is honestly a very surprising result, and was something that we were thrilled when we saw. So as we developed the system, we kind of did this training of this machine learning model to detect heads in a couple of stages with two different data sets. We didn't want to jump straight from a model trained on high resolution color images to low resolution infrared images. So we did this in a couple of stages of moderate resolution infrared images before jumping to our low resolution head detector, which is what we ultimately ended up with. Once we developed the system and exported it into a small form that could be mounted on an Android platform, run from a smartphone essentially, we integrated that system into the COVID ID Android application. And that's currently what we're working on is the head detector model is fully functional, and we're working on seeing if we can parse that information to get temperature data. And we already have some preliminary results, but we're looking to see if we can improve our accuracy with this temperature analysis with maybe more complex types of temperature analysis. But in either case, our system is fully functional. And we're thrilled that this technology is successful because it really shows that these kinds of machine learning based object detectors really have extreme power even when stretched to their limits with very low quality data. And the results of our system could actually serve as a proof of concept for the development of future systems that use this same kind of technology for a variety of applications that might not even necessarily be medical in nature and might be related to other industries. And so I'd like to thank you for listening to my presentation. If you have any questions, you can maybe stick around and you can ask me about them. Thanks.